Our objective today is to understand how to use a system of equations to solve word problems. And so this is going to come out of a couple different places. I'm going to pull some information. So this is from our packet. We're going to do one in, I think this is lesson 7. And then we're also going to do one in lesson 8. So those are the two lessons that I made that packet of, and so we're going to grab stuff out of both of those. If you happen to have that packet on you, it might make it easier for you to copy the word problems down because you can just copy it off the page. So if you happen to have the packet with you, if you go to page 235, we're going to write down the example about Gregory's Motorsports. So actually, let me go back for a second. Let's talk generically. You can go ahead and get that ready. But let's talk about the word problem process. Okay, yeah, that packet. Okay. Page 235 will be the first word problem we're going to look at the top. So word problem process number 1, there's going to be 2 unknowns, which leads to 2 equations, which leads to solve using a system. The number of unknowns tells you the number of equations you're going to have to translate. And that's how we're going to solve our system. Now, how we actually solve the system, we may be using substitution, elimination may be a better option. It depends upon what my problem looks like. So we have freedom as to how we solve it, but we're going to have to come up with 2 equations if there's 2 unknowns so that we can use our skills from the system, okay? So that's going to be our big thing that we're going to be doing is writing 2 equations from the information given. And again, when we write equations, we translate. And when we translate, we just write what it says. All right? So you are going to need to define each unknown. Okay. X equals John's age now. Y equals Mary's age now. So I'm going to have to define each variable individually. Okay? And you can use any letter that you want. So your audience has to know what you're talking about when you put this together. Now, I'm kind of glancing over some of the problems that you may have on homework, and some of them require you to know some formulas. So it's going to be really, as you're reading through, if you don't know a formula, then you're going to need to look it up. And then I would be making a flashcard of it and then committing it to memory. Because again, these formulas that they're talking about, the expectation is you know them. So when you're taking the SBAC test, which for us is going to be the Monday and Tuesday of the last week of April is when we start. And then we have like the middle of May, we're going to do a lesson in class, and then 2 more days that same week, I believe, we're going to actually go back and you guys are going to do a performance task. And the performance task is you solving one problem, but they're going to ask for a lot of information from you. So it's going to take maybe even 2 days for you guys to really work on that, okay? So SBAC is coming up. We got to get ready for it. So we need to define each unknown. We're going to translate our 2 equations. So I'm going to write that even though we kind of have it at the top there. and then we're going to solve the system. And the two strategies we talked about were substitution, so we get one variable by itself, and substitute its I forgot some letters, didn't I? And substitute that expression in for the variable in the other equation and solve. That's how we eliminate one variable. Or we also talked about elimination, and sometimes we have matching coefficients and opposite signs, so we can add and eliminate it that way. Sometimes we have to multiply an equation by a negative in order to get that matching coefficient opposite signs. And there may be other things we're going to have to try as well. Okay, but those are the two key strategies that we've learned on how to solve the system. Now, when we solved the system before, what did our answer look like when we were solving the system up through last week, or the week before, I should say? What did the answer look like?
Y equals mx plus b.
No, that was an equation. Kyler?
X.
No? What did our answer look like to the system? What was it describing? It was an ordered pair, because remember, regardless of how they asked us to solve, all systems are looking at where do those two lines cross? What is the point they have in common? And that point is written as an ordered pair. When it comes to word problems, we don't write the answer as an ordered pair. Okay, so that's crucial to remember. I should say answers are not written as an ordered pair. Okay, so we're not going to be writing ordered pairs as our solution. We're going to actually be writing a sentence that contains both answers. So answers written in sentence form, or sentence format, okay? So that's part of what we're going to do today is how do I go through a problem and recognize that it's going to be a system of equations, and then how do I go through the process and how do I write my answer, okay? So here's what our first problem is going to be. Directions are just going to say solve. So, first one, we've got Gregory's Motorsports. Has motorcycles. Those have two wheels. And ATVs. All-terrain vehicles. They have four wheels. In stock. The store has 45 vehicles. That together have 130 wheels. How many of each vehicle, so this I'm adding on, are in stock? So I want to know how many motorcycles and I want to know how many ATVs. Okay. So we have two unknowns. Right? What are they?
Motorcycles and ATVs.
Yeah, how many motorcycles and the number of ATVs. So we can use whatever we want as our variables. I'm going to choose boring X and Y. So X is going to represent the number of motorcycles. And Y is going to represent the number of ATVs. Okay, so how would I write an equation that deals with the fact that there's 45 vehicles altogether? What kind of equation would I write? And if you got the packet, I want you to close it up. How could I write an equation that tells me I have 45 vehicles in the store? Well, what are the vehicles that are involved in this problem? Motorcycles and ATVs. Okay, so if that's what I know the vehicles are, and I know there's 45 of them, and I have variables written out, how am I going to write this equation? Jonah? What's the equation?
Are you asking me?
Yeah. I'm dealing with this guy. 45 vehicles. How do I write an equation that tells me about 45 vehicles when X is the number of motorcycles and Y is the number of ATVs? Oh, people, this isn't rocket science. This is easy. I have a total number of vehicles. There's a pile of motorcycles and there's a pile of ATVs. What mathematically am I going to do with them? What am I going to do with them mathematically? I'm going to add them, okay? Jonah, tell me again.
X plus Y plus
Yeah. The number of motorcycles plus the number of ATVs equals 45 vehicles. Okay? So everybody should be writing this down. How am I going to write an equation that talks about the number of wheels? So now I want to write an equation that says equals 130. How can I figure out how many wheels I have on X number of motorcycles?
Well, you multiply it by 2.
Yeah, I multiplied by 2. So I have 2X represents the number of wheels on motorcycles. And how do I represent the number of wheels on the ATV? Oh, not X, 4Y.
Plus
Okay, now comes the fun bit. I need to solve the system. So what are some options that I could use? What are some thoughts that you guys have in order to get these equations so that I get them down to one variable? I have multiple options here. Okay, multiple choices. Jonathan, what are you thinking? Subtract. Okay, so you want to use substitution by creating an equation that has a variable by itself. And if we do that with the y, this equation now becomes x equals 45 minus y. So now I have an expression that means the same thing as x. So I take that and I substitute it into x in the other equation. So now my equation becomes 2 times the x value 45 minus y plus y, or sorry, 4y equals 130. So remember, I have to substitute it back into the other equation, not the equation where I got x equals 45 minus y. And then what do I do at this point? I'm going to have to distribute, right? Because I can't do anything with those parentheses. So 2 times 45 is 90. 2 times negative y is negative 2y. And then I write out the rest of the equation. Okay. I have some like terms. What's negative 2y plus 4y? I had a positive 2y. And then I'm going to subtract 90 from both sides. Go over here. And I get 2y equals 40. And if I divide by 2, I get y equals 20. So y represents the number of ATVs, because that's how we defined it. So how do we figure out how many motorcycles? Plug it back into either original equation and solve. This is the easier one. So I have x plus 20 equals 45. Subtract 20. and I get x equals 25. So how I write my answer is this. There are 20 motorcycles and 25 ATVs in stock. Okay, and that's how I'm going to be writing my answer as a sentence. Yes? Oh, you're right. I did it wrong. You're right. Sorry. Y was the 20. So we have 25 motorcycles and 20 ATVs in stock. Okay? And again, I could check that by multiplying by the number of wheels and see if I get 130, because the two do add up to equal 45. So 25 times 2 is 50. 20 times 4 is 80. That works. But the other way, I would have had 20 times 2 is 40, and 25 times 4 is 100. That would have given me 140 wheels, and I only had 130. So that would have been a quick, easy way to make sure. Thank you for catching that. Now, can somebody give me perhaps a different way we could have solved that equation? What could we have done to make a match happen with one variable? So look at your original red and blue equations. What could I have done to, let's say, make the x's match in such a way that when I added the equations, the x's would eliminate?
To subtract action in a sense.
I can't, no. That's exactly what we were doing. Kyler?
You, would you multiply everything by 2?
Close. In order to add them together to make something eliminate, I have to add opposites. So I wouldn't just multiply by 2 to get my x's to go away. I would multiply by negative 2. And that's another way to do that. That's another system using elimination, another way to use it. Okay? All right, good. Let's try another one. This one is on page 243. So this one says, Mary Ann sold 20 necklaces and bracelets at the craft fair. She sold 3 times as many necklaces as bracelets. How many of each did she sell? So every time we're solving these word problems, the thing that we're looking for is we're looking for a how many of each. It's always what we're going to be looking for. How many of each? Okay, so Mary Ann sold 20 necklaces and bracelets at the craft fair. She sold 3 times as many necklaces as bracelets. So how many of each did she sell? Okay, so what are we trying to figure out in this problem? What are our 2 unknowns in this problem? Jonathan? Number of necklaces and the number of bracelets. Now, sometimes when I choose my variables, I don't always choose x's and y's. We're used to that when we were solving our systems, but what I tend to do sometimes is I pick variables that represent the items so I can track them better. And I think I would not have made my mistake that I did, that you graciously caught me on, Samantha, if I had used better variable choices. So what I'm going to do is pick a variable that better represents necklaces and one that better represents bracelets than X's and Y's that have nothing to do with either one of them. So I tend to use the first letter. So I'm going to let N be the number of necklaces. Let me do this in a different color. And what do you think I should use for the number of bracelets? B. Okay, we want to have things that make sense, not just the first initial of our name. Number of bracelets. Okay. There are two numbers that I see in this problem, and so that means I got to figure out an equation for each one that uses those extra numbers. So the number 20, what does 20 represent? Joy?
The total of how many she sold.
Total of how many she sold. So how can I write an equation using that 20, knowing that N is the number of necklaces and B is the number of bracelets? How would I write that?
You would go, so, N, X,
Oh, we don't have any X's.
sorry, N, times the number, no, that's the number next.
How can we write an equation that uses 20, the number 20, which is she sold 20 necklaces and bracelets. So we know it has to equal 20.
M plus B.
You got it. The number of necklaces plus the number of bracelets is 20. Now here comes the second sentence. She sold 3 times as many necklaces as bracelets. So you have to think, what does that mean? What did she sell more of? Did she sell more necklaces or did she sell more bracelets? Okay. Says she sold more necklaces. So how we translate this equation is we're going to pair up the math with the guy at the end. Necklaces is what she has the most of. So we're going to have N, and it's going to be the same as 3 times the number of bracelets. So I have to increase the number of bracelets threefold in order to represent the number of necklaces. Okay? Now, look at that system. What are we going to do to solve this system? What's it totally set up for us to use?
3B, the 3B legends.
Yeah, this is a perfect problem for substitution. We have an equation that has N already by itself. We didn't have to work so hard on this one. So what I'm going to do is replace N with 3B and then write out the rest of the equation. So plus B equals 20. So I have some like terms. What's 3B plus B?
4D.
So I have 4B equals 20, and I divide both sides by 4, and I get B equals 5. So that's half of my answer. Then I need to figure out how many necklaces. So this is probably the easier of the two equations. And the number of necklaces is going to be 3 times the number of bracelets, which is 15. So, wow, when a substitution's already ready to go, it's much faster to get that done. So we would say Mary Ann sold, let's see, 15 necklaces. Notice this time it was a lot easier to figure out which one was necklaces because of the N, and 5 bracelets at the craft fair. So it's good to include the names of people. It's good to include some background information when you're solving these problems in your answer. Okay? All right. Let's do another one. And I'm going to give you a slight, it's going to be very similar to this one. So for those of you who have your packet, it's page 245, and it's at the bottom. And this one deals with cookies and cakes, which makes me hungry now. So a total of 75 cookies and cakes were donated for a bake sale to raise money for the football team. There were 4 times as many cookies as donated as cakes. How many of each were donated? So a total of 75 cookies and cakes were donated for a bake sale to raise money for the football team. There were 4 times as many cookies donated as cakes. How many of each were donated? All right, so what's going to be a little bit of a challenge in this problem? Yeah, we can't use C and C. That's not going to work. So we're going to have to come up with a different one. You think, well, maybe K, but they both have a K in there too. So you could do double if you wanted. C, but then that could be cakes as well. So maybe SO and CO and CA. Or we could just say O and A, or we could say X and Y. But unfortunately, we're going to have to track these slightly differently, or just keep very clear what does X represent, what does Y. So I'm going to go back to the old X and Y. I know, how boring. So X is going to be the number of cookies, and Y is going to be the number of cakes. So what I want to do is kind of go through the notion of that second sentence. There were 4 times as many cookies donated as cakes. And so for each one of these, let's see, this was your cake, and this is your cookies. It says there's 4 times as many cookies donated as cakes. So that means we have 4 bars of cookies to 1 bar of cakes. So it took 4 X's to represent 1 Y. Drawing that picture, just wrote an equation. 1 cake, I'm trying to change colors. 1 cake oh, I have mine backwards, sorry. That doesn't work. I want to erase these 2. So my number of cakes is my Y, and the number of cookies, it took 4 groups of them. There we go. So again, notice how we did that last time? That it took for the 4 of these to get to the same, for him to match. These don't equal to each other, right? They're not the same. It would take me 4 of these to get them to match up, okay? So that says that with the number of cookies, which we chose to be X, it would take 4 times the number of cakes to make them equal. So that's how we're taking, and again what we did, we took the 4 times and we multiplied it by the guy at the end. Okay? Now, what's the other equation that goes with the number 75? What's the other equation that goes with the number 75? It's the same one we keep getting over and over again, right? Right.
X plus Y equals 75.
Yeah, the number of cookies plus the number of cakes equals 75. So again, what's our strategy to solve this one?
Substitute for Y and for X.
Yeah, pretty easy. So we have 4y plus y equals 75. So that ends up giving me a total of 5y equals 75. And we divide by 5. And we get y equals, let's see, that goes in twice, 15. So y goes with cakes. So we had 15 cakes. To get the number of cookies, we can plug that answer back into the other equation. And the number of cookies is going to equal to 4 times the number of cakes. And we get 60. Okay? So when I write my answer, I say 60 cookies and 15 cakes were donated for the bake sale. Okay? So our answers are going to be in sentences. Now I'm going to tell you what sounds kind of funny for the questions that you have on homework. They will tell you to write the system of equations. They will tell you to solve it algebraically. That means use substitution or elimination. And then they will tell you to interpret the solution. Interpret means to write out the answer in a sentence, not to write it as an ordered pair, because an ordered pair wouldn't make sense in this question. Okay? So what they're asking you to do is exactly what we have here. All right? So that's for your homework tonight.